All right, hello people who are watching this video. Here's the homework for section 8-2. There are lots of random weird problems, but there's only 12 of them, so he should be okay. What?
Up there until Kellen gets back with my papers.
Just write them from Trevin's paper.
Yeah, just cheat off of Trevin's paper, or like write them off there. Okay, let's go to 8-2, properties of logs. This is the little bit funner stuff of logs. This is what I like to do. This is a little bit funner, okay? Here we go. Solving log equations by using definitions. Go to example 1. All right, here is rule number 1 when it comes to interpreting logs. So I'm a pretty fun way. Here is rule number 1. Are you ready? If you get stuck in log land and you cannot do anything else, you change him to exponential land. So on example 1, I have no idea how to solve this thing. So what I'm going to do is I'm just going to play around with it and see if I can come up with something. I'm going to switch him to exponential land. All right, when I switch him, he is 4 to the 5 halves power equals x. Okay, now, the 5 halves power, you can type this into your calculator, 4 to the 5 halves, and get the answer, right? But here's what the 5 halves power means. Ready? The 2 on the bottom means the square root, yeah? So this is like the square root of 4 to the 5th power. Do you see how that works? Okay? 4 to the 5 halves power is the square root of 4 to the 5th power, because the 2 on the bottom means square root, yeah? All right, what's the square root of 4? 2. What's 2 to the 5th power?
Wait, 32.
That's the answer. That's all. Okay? We were in log land. We were stuck in log land. We switched to exponential land and we solve, and that's all, right? 4 to the 5 halves power is 32. That's it.
Let me prove it.
Good?
What?
Wait, can you explain that?
Yep. So we're here. We switched him. We switched him to an exponential function. Yeah, you got that? Okay. Anytime you have a 2, like a fractional exponent, like 5 over 2, this is like 4 to the 1/2 and then to the 5th power, right? 5 halves is 1/2 times 5, right? Okay, the 1/2 power means square root, right? That's what 1/2 power means. So this is the square root of 4, that thing to the 5th power. What's the square root of 4? 2, and 2 to the 5th power is 32. So 32 is what x is, and that's how you solve. So when we are in log land and we cannot solve anything else, that's rule number 1. Always, we're going to come back to that at the end of the chapter, every section till we get to the end of the chapter. When you are stuck in log land, convert to exponential land. Let's go to example 2. Here is a rule, and I like this rule. This is awesome. We have log base 5 of all of this stuff equals log base 5 of 4x. Kind of like when we did exponential functions, if I would have like 3 to the x power equals 3 to the 5th power. Guess what? X equals 5. You can cancel them out. Look over here. Log base 5 of that stuff equals log base 5 of 4x. We can cancel those two out, yeah? Now we got to do a little bit of work. So I've got 2x squared minus 6 equals 4x. Okay. Now what would you like to do?
Divide by 4x.
I'm going to, we can't divide by 2x because the 6 doesn't have an x. Good thought. I'm going to divide everything by 2 though. Sure. Right? We can reduce everything by 2. So this guy will become x squared minus 3 equals 2x. Then what?
Subtract the 2 over.
Yeah, let's subtract the 2x over because then we will have a trinomial, right? Okay? So this guy will be x squared and then what? If we put him in order. Minus 2x. Minus 3 equals 0. Okay, do you remember what we do at this point? This is a?
You break it down.
Yeah, that's a simple trinomial, right? What can you multiply to get negative 3, but when you add them, give you negative 2?
1 and negative.
You're close. 1 and negative 3. So x minus 3 and x plus 1, yeah? Negative 3 times 1 is negative 3. Negative 3 plus 1 is 2, yeah? It's negative 2, I mean. Okay? Do you see how we did that? I moved everything over. I crossed out my logs, and now I'm doing all the algebra stuff. So I get him to be a simple trinomial. We break him down to here. He's equal to 0. Now what do I do at this point? I have my 2 bubbles. I have him equal to 0. Now what? X equals 3, and x equals negative 1, right? We just flip those signs. Do you remember doing that? Yeah. So those are my two answers. X is 3 and x is negative 1. Cool. Very nice. Got it? We're just doing the algebra stuff. Okay, this is how logs operate. We're learning the properties of logs, how they operate. Okay? Example 3. Let's go to, all right, let's talk about this. Go to page 410, and here off to the side, I'm going to illustrate these properties, but I do a better job over here. This is like a little simplification. So we have something called the product, the quotient,
Quotient's the answer of division.
division, and then power. Okay, we have the product, the quotient, and the power. Product, if you want to write the whole word out. Product, quotient, power. Okay, product, quotient, power. Here's how this works, okay? All right, when we're doing products, let's say we are taking x squared times x to the 4th power, okay? If I take x squared times x to the 4th power, what do you get?
X8.
X to the 6, because when you are doing the product, you actually add the exponents, okay? This is similar to how things operate in log land, all right? So here's how log land works. Let's say I have log base 3 of x plus log base 3 of 5, let's say. And I am trying to condense those. Okay, they are both the same base, log base 3, log base 3. If they were not the same base, I could not do this. But here's how this works, okay? I am going to have log base 3 as my final answer, but what goes inside of here if I'm trying to condense those? Plus means multiply, and multiply means add, right? Multiply and add go together. If I'm multiplying these together, I add the exponents. If I'm adding logs together, I multiply the inside stuff. So if I'm trying to condense log base 3 of x plus log base 3 of 5, it will be 5 times x. That's how I condense him, right? That's how I put stuff together, okay? This is just simplifying things, right? That's how things, yeah, kind of like the opposite of exponentials, right? Exponentials and logs are kind of opposites, okay? So let's talk about quotients. Let's say I have, I'll use a different color. Let's say I have x to the 4th divided by x to the 1st power. Okay, he is x to the 3rd power because what you did when you're doing a quotient is you subtract. Okay, so let's say I have log base 3. I'll just do the same thing. Log base 3 of x minus log base 3 of 5. If I try to write those as one piece together, I'll still have log base 3, but what will it look like? You're dividing, right? How do I divide those two things? Nope. X comes first, so the x has to be on top. It will be x divided by 5 when I put them together. Do you see how that works? Minus means divide. Divide means minus. Plus means multiply. Multiply means plus, right? That's how it works in log world, okay? The same as it does exponents, right? These are exponents, how they operate, you subtract them. Here, when I'm subtracting, I put them together, and that's division, yeah? That's how those things operate. Got it? Okay, last thing is power. Okay, before you write this down, just watch, okay? Just watch and help me figure out what this is going to become, okay? So let's say I have, something really big. Let's say I have, let me make it a little bit bigger. There we go, there's my font. Let's say I have log base 2 of 10 to the 3rd power, okay? All right, don't write this down. Everybody just watch. Log base 2 of 10 to the 3rd power. Okay, let's talk about what happens here. We have a power, and the power is 3, and let's talk about what can happen to him. Ready?
Divide by 2.
Nope. Log base 2 of 10 to the 3rd power. Okay, this is the same thing as log base 2. Let me write this in a different row. Log base 2 of 10 times 10 times 10. Agreed? Okay? That's what 10 to the 3rd power means, is 10 times 10 times 10. But what does multiply mean in log world? Add. So if I try to break these into 3 pieces, this would be log base 2 of 10 plus log base 2 of 10 plus log base 2 of 10. And how many are there? 3 log base 2 of 10. Okay, so let me show you how we cheat and we go from this to this. If you have a log, this is very important. If you have a log and you have an exponent right here, this 3, he can magically come down in front like we did there. And you have no exponents anymore. This 3 can come down in front, okay? That's the power property of logs because that's how logs operate. Multiply means add, and then I can condense those. There's 3 of them. So any exponents that you have behind a log come down in front. Now, what is not true is for exponential functions. Let's say I have x to the 6th power. That's obviously not the same thing as 6x. I cannot just pull that x, that 6 down in front. But in log world, if this was log of x to the 6th, that's going to be the same as 6 log x, right? Now, question. Hold on, I'm going to answer your question just now, okay? Notice that in this problem, when I was illustrating it, I didn't put a number here. I didn't put a base there. What is the base if there is no number? It's base 10, okay? So everybody remember that. If I don't put a number there, it's in base 10 because that's what your calculator thinks in, okay? We are, us and every, I guess, nation operates in the base 10 number system, okay? Like we are in a base 10 system. Here's what base 10 means. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Stop.
11 is kind of similar to 1. Then we go through all the 10s. Then we start with 21, 22, 23. It's all in units of 10, right? Because 21 and 31 and 41, those are all similar to like the ones unit, right? So that's what the base 10 number system is. That's why we operate in log base 10, okay? Your calculator operates in log base 10, okay? What?
How can we use feet instead of meters?
I don't know, because we're stupid. We're one of the only countries that uses the customary system. We should use metric because it's way easier, but whatever. Okay, all right, so let's talk about how we do example 3 then. This says log base 3 of 5 is this decimal number. Just put that in your pocket and like hold on to it for a second, okay? This means nothing right now. If you type into your calculator, which you don't know how to do yet, but if you were to type in log base 3 of 5, you get that as a decimal number. I want to use this information to figure out what this is. Log base 3 of 405, okay? What in the heck is happening there? Log base 3 of, I don't want to do that. Can I switch this problem? Yeah. Let's do this. Let's do this. I'm going to change this instead of being 405. Let's baby step you into this, okay? Let's change this to say log base 3 of 25. Let's say that. Log base 3 of 25, okay? I'm going to baby step you into it. So instead of 405, instead of a big number, let's do log base 3 of 25. Okay, I know what log base 3 of 5 is. So what I want to do is I want to figure out what log base 3 of 25 is when I know log base 3 of 5, right? How do I write 25 as 5? Right, this is the same thing as log base 3 of 5 squared, right?
Oh, so it's equal to...
Or that 2 can come down in front, which is 2 log base 3 of 5, right? But what is log base 3 of 5? That decimal number, right?
Yeah.
So really, I just have to take 2 times that decimal number, right? What's the decimal number? 1.465?
2.9.
Okay, you see what I just did? 25 is the same thing as 5 squared. The 2 came down in front, so all I have to do is take 2 times that decimal, right? Which is like 2.93. Yep. Okay, you see how that works? Ish? All right, we want to write everything in terms of the stuff that we know. Let's do example 4. So we know log base 3 of 5, and I don't like that question. We don't know that yet. I don't like that question. I don't like that question. Okay, let's change this. Let's change it to be 3 over 5 instead of 9 over 5. Okay, we'll make it a little bit easier. Log base 3 of 3 over 5. Here's how this works. Okay, we have a division. What's division mean in log land?
Subtraction.
Subtraction. So if I want to separate him, he is log base 3 of, hold on, log base 3 of what?
3 minus 5.
3 minus log base 3 of?
5.
5, okay? All right, now, we know that log base 3 of 5, this guy right here is what? That 1.465. This guy is 1.465, okay? But what's log base 3 of 3? Log base 3 of 3, if we remember what we did yesterday, log base 3 of 3, if I set it equal to x, this means 3 to the x power equals 3. What's the exponent?
0. No, wait.
3 to the first power is 3, right? So this whole thing is 1, so I have 1 minus 1.465. Now, that will be the case whatever your base is. Log base 6 of 6 is 1. Log base 42 of 42 is 1. Log base -7 of -7 is 1, right?
Yep.
Okay, so if your base and the number that you're taking log of are the same number, it's always going to reduce to 1. All right, so that's a little trick. So log base 3 of 3, cancel that to be 1, minus this guy is 1.465. We subtract those, we get 0.465. That's what we get for an answer. Okay, negative 0.465. Those are the rules for how log works, yeah? Okay. All right, let's go to this one. Okay. Log base 2 of 6, we know this guy, all right? I'm hinting like down, I'm cheating by looking down at the next one. Log base 2 of 1296. They say, I'm just going to look right down here, that 1296 is the same thing as 6 to the 4th power, right? So this guy is log base 2 of 6 to the 4th power. That's what 1296 is. I replaced it with 6 to the 4th power, but then what do?
You take 4 and put in front.
4 goes in front. So 4 times log base 2 of 6. Do we know what log base 2 of 6 is? That decimal number right there?
Yeah,
So take 4 times 2.585.
10 points.
Whatever that is. It's going to be bigger than that.
It's
No, you might be right.
Yeah, it's 10 points. 3.
What? 10.34?
3.5. 3.4.
10.34?
Ah.
Okay. You were close. That was good. That was a good estimation. 10.34. So it's just all using manipulations. 1296 was 6 to the 4th power. 4 comes down in front. I just take 4 times whatever that decimal is. That's it. Okay? Let's go. Example. I don't want to do example 6. Oh, that's it. Hey, look at that.
So 2, 4.
Will you teach me how to use the right calculator? Because mine's
Because yours is difficult? Ugh. I hate your calculator. Okay, there's homework assignment. All right? Okay, and begin. I'm gonna stop the video.